So this means that you would then need to add that amount onto your BMR, as it's more than what you'd be doing if you were just laying down all day. So the athlete that I will be analysing is Rebecca Adlington. So she was an Olympic swimmer. She's now retired, but I'm just going to be doing this off if she was still swimming. So her on a typical day, she would need to consume around 6,000 calories to maintain her energy levels. This is due to her training schedule, which includes 4.5 hours of swimming a day, and 1.5 hours of strength training. So I worked out her METs for this amount of exercise, and it comes to 4,190. I also worked out her basal metabolic rate by using her age, height and weight, and that came out at 1,529, which you'd need just in a basic day. So when you add those together, it comes to 5,719. So that's the amount of calories that she'd need to consume in her average day based on the amount of activity that she does. So obviously it would probably be a bit higher than this because your METs include just walking around as well, so it'd probably round up to around 6,000 calories. So for the average woman, it's only required to have 2,000 calories a day, so she's having basically triple the amount of calories needed due to the amount of physical activity that she takes part in. Things that could affect her calorie intake wouldn't really be climate, because when she's training, the swimming pool has a regulated temperature, so there wouldn't be any need for shivering or sweating. So the climate wouldn't be a problem there, although age would probably affect it slightly, because now obviously she was tired because she's nearly 30. So her BMR may be slightly lower because she's no longer in the stage of adolescence where she'd be growing. But obviously because of her training, which then leads on to physical activity, she will be building muscle mass, so which requires more energy. And this also links sort of to climate, because where she's doing a lot of physical activity, that would then cause her to sweat, which then sweating requires more energy to do so. And then gender would affect it, because she's a female, she'd have a lower BMR, although as she's an Olympic standard athlete, she does have a very high amount of muscle, which would probably raise the BMR, as she'd need more energy to move her muscles. So that's the end of my PowerPoint. Thank you.